Hello again, and welcome to this video on deployment considerations when implementing IWAN with APIC-EM. I'll be breaking this video up into two parts. In the first half of the video, we'll discuss deployment considerations from the perspective of APIC-EM, things like firewall policy, NAT and PAT, and deployment modes. In the second part, we'll flip-flop and review things from the perspective of the remote device. So let's get started. APIC-EM with the IWAN app, as you may already know, is a key component to the IWAN solution, being the centralized controller that orchestrates both device onboarding and provisioning. For information on installing APIC-EM in a virtualized environment, check out the installation overview video found earlier in this series. That said, when considering where within your network to place APIC-EM, you have three options, or deployment modes with which to review. First, and probably the most obvious, APIC-EM can be placed behind your corporate firewall on the internal network. This deployment mode has the advantage of offering the highest level of security for APIC-EM with minimal changes to internal infrastructure. That said, several IWAN services such as plug-and-play and certificate provisioning rely on APIC-EM being externally reachable by remote devices. This mode will require NAT and PAT configuration on the Internet Edge firewall if using a private IP address, as well as security policy updates to allow required traffic. More on this a little later. Alternatively, APIC-EM can be placed in the DMZ. This mode offers slightly relaxed security so that remote devices can reach the controller, but may require changes to your firewall to allow communication between devices that live on the internal segment. Again, NAT and PAT configuration may be necessary on the Internet firewall if you're using a private IP address to ensure that certain traffic is delivered to the controller from the Internet. Lastly, APIC-EM can be deployed in a hybrid setup with two NICs. This allows one NIC to exist within the DMZ for external reachability, and one NIC to exist within the internal network for internal reachability. Take note that, as with most network devices, only one default gateway is supported, so choose wisely on how APIC-EM will communicate with the devices to avoid asymmetric routing and security policy issues. Now that we've decided where APIC-EM will be located within your network, let's review some services it will run so that you can adjust your security policy accordingly. First, notice that there are three ports that need to be opened on your firewall to allow external communications inbound towards APIC-EM. These may require both security policy updates as well as NAT and PAT forwarding to ensure traffic is properly delivered. TCP port 80 and 443 will facilitate zero-touch provisioning through the plug-and-play app, as well as certificate provisioning through SCEP. Optionally, consider opening up UDP port 162 for the reception of SNMP traps from end devices. In the outbound direction, i.e. from APIC-EM towards the Internet, there are four services that will need to be allowed. TCP ports 22 and 23, SSH and Telnet respectively, will be used for device configuration provisioning. As a side note, Telnet is only used when devices are added using Telnet through device inventory in APIC-EM. ICMP will also need to be allowed to permit reachability checks, and for platform queries, SNMP should be allowed as well. And lastly, make sure to allow NTP through your firewall to allow APIC-EM to synchronize its time. Now that we've seen what's required for the controller, let's shift perspectives and take a look at our hub routers for a moment. As with APIC-EM, there are a few deployment modes to be aware of. These modes will be covered in greater detail in a future video, but for discussion's sake, let's review each quickly here. First, the IWAN router can be installed in place of the existing WAN edge router. This mode is somewhat self-explanatory and is usually a fairly straightforward process. You'll want to plan on a brief routing interruption with your service provider as front door VRF configuration is added, however. Alternatively, consider the iBlock mode of deployment. In this mode, existing WAN edge routers are left in place and the new IWAN router is placed behind them. The advantage to this method is that no downtime is incurred to get IWAN set up, and IP addressing can be engineered in such a way that moving the IWAN router to the WAN edge in the future can be done with relative ease. Once satisfied with your IWAN application policy, simple routing adjustments can be made to influence traffic through the iBlock router after testing. iBlock is a great choice to consider when migrating to IWAN. Just like APIC-EM, remote routers also have a set of services that need to remain open for proper operation. These may require security policy updates as well as NAT and PAT forwarding. TCP port 22 and 23 need to be allowed inbound towards the remote device for configuration provisioning purposes. Likewise, inbound UDP port 161 should also remain open to allow APIC EM to query the remote device for platform capability. For reachability checks, ICMP echo need also be allowed. In the outbound direction, TCP port 80 and 443 will facilitate zero-touch deployment, while UDP port 123, or NTP, will provide for accurate timekeeping. Optionally, consider allowing UDP port 162 so that the device can send SNMP traps to APIC EM. UDP port 500 and 4500 should also be allowed so the devices can successfully exchange ISAKMP control messages to facilitate VPN setup and teardown between hubs and spokes. And last but not least, ESP should be allowed so that encrypted traffic can reach the IWAN router. As always, if you have any questions about what you've seen today or have a suggestion for a use case that you'd like to see, feel free to reach out to us at iwanapp-pm@cisco.com. Thanks for watching, and I'll see you on the next video.